Welcome, everybody. Imagine you're getting ready to give a presentation at a large conference. After practicing for hours, wouldn't it be nice to have a metric telling you aced the material and are ready to give your speech? I'm here today to tell you that HP has a solution. Building upon the recently announced HP Reverb G2 headset, we are continuing to push the boundaries of what's possible in XR. To truly begin to deliver on the promise of XR, we knew we had to make it personal, putting the human back at the center of the technology. We are pushing the envelope to bring together XR solutions, machine learning techniques, and sensor fusion in a single platform designed for enterprises. I am Brianna, Product Manager of the HP Omnicept solution, and today I'm thrilled to be announcing this exciting innovation. With robust security and the highest standards of privacy protection, the HP Omnicept solution is comprised of two main components. First, we've created an advanced headset with integrated sensors to capture unbiased biological responses, such as heart rate, pupillometry, and facial expressions. Secondly, this sensor data is then fed into our new HP Omnicept SDK, which uses machine learning algorithms to train a cognitive load inference engine that can provide valuable insights, such as how a user's performance varies when exposed to new situations, or maybe even tell a user when they're ready to give their speech. Developers and enterprises can then use this solution with both Unity and Unreal game engines to develop applications to create personalized, user-centric VR experiences to improve people and business performances. Before we dive into the details, let me introduce the one and only Chandrakant Patel. He is HP's Chief Engineer and Senior Fellow. He will be sharing industry trends and the vision we see from HP. Over to you.
Greetings, everyone. We are thrilled today, given the launch of Omnicept. Our excitement stems from the value this technology is poised to deliver. Indeed, if we look at the challenges we face as society, it is time for value-driven solutions at the intersection of supply and demand. As we look at our day-to-day lives, our day-to-day needs, the demand side needs, food, clothing, shelter, power, water, waste, transport, health, finance, and so on, including cybersecurity and privacy, at home, on the go, and at work, are being met by a pool of supply-side resources. Power, water, waste, transport, and so on. This supply-demand framework is being rocked by megatrends, social, economic, and ecological megatrends. And things like COVID-19 are accelerating this challenge. So, these megatrends have caused us to pause and look at how should we use technology for betterment of society. And that's where Omnicept fits very well. So let's take as an example, from a megatrends perspective, the aging demography. In the West, we face this challenge. We have an aging demography, and that has created challenges for us. Our infrastructure, power, water, waste, transport, nuclear power plants, the people who run this infrastructure, the rail system, they are retiring. How will we train a new cadre of people to take that on? And with all the domain depth that they have, how can we take the few who are available to take care of the range of systems that meet our demand side needs? So how will we go from one to many in managing physical systems, and how will we train new personnel? That's a big challenge. Then there are other megatrends, such sustainability, resource constraints due to sustainability, and on and on and on. So these megatrends have caused a major issue that we must take a look at in the context of the technology trends. From a technology perspective, let's look at the technology landscape. The 19th century was the machine age. It was the age of the steam engine and the power utility. It was an age of great domain depth. The 20th century was the information age or the cyber age. The latter part of the 20th century was about the internet. And the internet created a gigantic abstraction layer. We sat above this abstraction layer with our cell phones and apps. There was tremendous innovation in e-commerce and social media. It was, like I said, a breadth-driven age. Now comes the cyber-physical age. The 21st century is the cyber-physical age. It's the integration of machine and information age to create cyber-physical systems. Tesla Model S is an example of such a cyber-physical system. A system built on fundamentals of mechanical sciences, fundamentals of physics, heat transfer, solid mechanics, physical fundamentals, the domain knowledge of the machine age, combined with the information age knowledge, the cyber age knowledge. And it's a cyber physical system that delivers a unique experience. Consider other systems. Trains, for example. I recently hosted a customer who they were involved with the rolling stock, the trains that they have. Their challenge was, hey, Chandrakant, the people who run this are retiring. In this context, that's a cyber physical system. The challenge here is, how do we manage all this with people who are retiring? So one opportunity that technology provides us, a cyber physical technology, is the rise of VR and things like VR with haptic holography, haptic analytics. So can we build VR systems that will enable one person to manage many, many trains? And also, can we build VR systems where that person can create legions of people who will manage many trains? Similarly, think of doctors and healthcare. In healthcare, as I have said earlier, that's an area that is also impacted greatly by demographic change. In this country of ours, in the United States, in a country of 300 million, there are 4,000 cardiothoracic surgeons. My son, who's studying to be a cardiothoracic surgeon, he's already a decade into it, and it'll be quite a while before he gets specialized in that. Such subspecialization are so few in number. How can we make one person do robotic surgery of many? Or by the same token, how can we make that person effective in training new cadre of people? So that therein lies the challenge. Cyber physical systems are complex. People who are running it are few and far between. We have to come up with a method so we can scale. And therein lies the excitement with Omnicept. It's an exemplar of the cyber physical system. And what we are calling, it's the rise of cyber physical human systems. So 19th century was the machine age, 20th century was the cyber age, 21st century, early part of the 21st century has been about cyber physical systems, and now we enter cyber physical human systems. What do we mean by that? HP's Omnicept platform is setting the course for this exciting opportunity. It's a system with integrated sensors that enables us to integrate the human being with physical systems. So in this visual you are seeing, I'm connecting it back to the Tesla automobile. My daughter works at Tesla's factory in Fremont. The factory of tomorrow will have a Tesla automobile, like a sedan built with another version, which is an SUV, and may even include a truck. So tomorrow's systems are going to have heterogeneous mix of systems being built. And the same example I gave earlier, experts will be few and far between. We expect systems like Omnicept to be integrated with the person so that one person cognitive load could be understood. We are assimilating data using the sensors, and we are using our inference engine to understand the cognitive load of the person, so that cognitive load of the person enables us to make choices on that assembly line. That assembly line is moving fast, lots of machinery moving. Can we use our system to understand the cognitive load of the person? So the person is impedance matched with the machinery in the factory. We reduce the mistakes, and we make sure that we don't overstress the person while at the same time improve the productivity. So we are very excited, given this additional dimension that Omnicept will bring in the cyber-physical system, the cyber-physical human system. The same can be utilized for training people. As we train people in flight simulators and in that surgery room to create subspecialized personnel, Omnicept could be part of that simulation engine, so we can understand the cognitive load of the person, how well they are learning, or what the level of stress they are in when errors are induced in a simulation. So we see Omnicept as setting the course, a very exciting course in this new world. And lastly, VRHP, we have a pedigree and a brand name associated with cybersecurity. And in this case, cyber physical human security. So that the data that will be assimilated, we will use our principles of cradle to cradle to make sure that not only is the data secure, but we recognize and respect privacy. So that is supremely important to us. So this visual that you see in front of you, we are excited about it. Cyber physical human systems, which are secure from end to end, with HP's brand reputation, to make sure that we always have your confidence in security and privacy. Thank you very much. And I am really excited to introduce our next speaker. Jeremy Balanson is a key industry thought leader in this space, and he's also the founding director of Stanford's Virtual Human Interaction Lab. So let me pass the baton over to Jeremy Balanson, and thank you for listening to me.
In this garage, an industry was born. Literally, Silicon Valley started here. So in this garage, they were tinkering physically. At Stanford, what we tinker with is not tools like this. We tinker with virtual reality simulations and test what they do to the mind. My name is Jeremy Balanson. I founded Stanford's Virtual Human Interaction Lab. I'm a professor that studies virtual reality. If you think about what makes us special, what makes all of us different from one another, there's of course a genetic component, but it's really about your experiences. If you think about the top 10 things who've made you, you, a lot of those are going to be 5-minute, really intense, wonderful, and maybe some not so wonderful experiences along our journey. What VR does is it gives you this fantastical experience that could be built by any programmer to do anything. However, the brain treats it as if it were real. And so working with HP, we're designing an amazing set of experiences that really make you rethink hard issues. And one of our lines of research for 15 years now has asked the question, how are we going to use VR to solve tough problems? And the paradigm of the virtual mirror is you walk up to a mirror, you put on the goggles, you're in virtual reality, and you see yourself. We've scanned your body and it looks like you, and then we hit a button and you become a different gender, a different race, and you then occupy someone's body, you walk a mile in their shoes. VR becomes a tool to study how other people experience the world and bridging that gap between the self and others. We treat virtual reality as a medium, and we ask the big question, what is a person in an age where VR is everywhere? How is this medium going to change the world?
Thank you, Chandrakant. My name is Jeremy. You saw me in the HP garage, which was a real treat to be there in the garage. Now you have the real Jeremy here with you today. So I'm thrilled to be here today to talk to you about a project that I've been doing with HP for about a year. As many of you on this call know, that the killer app of VR is training. Since the late 1920s, where there was a flight simulator, we've all been looking at simulation for training. But in the last few years, what you've seen is a proliferation, and it's not just astronauts and pilots, but people all over the country using VR to train every day. What we wanted to work on this project was to try to understand with physiology how you can figure out what's going on in the mind and the body in order to better train people and to better understand people when they're using VR. We decided to focus on cognitive load, and cognitive load to me was the sweet spot on where to start. And the reason it's such an amazing place to start is it combines the best of two worlds. Number one is great science. We've known about cognitive load, for over 100 years, been studying it as psychologists, understanding what causes it, how to measure it. So we really have good academic background to not just go stabbing in the dark at whatever signal we can chase, but to start with fundamental science to understand an important cognitive aspect of work. It's also combined with good business, meaning if you know if someone's overloaded, there's a lot you can do with that to help people get better at their jobs, to live longer, better work lives in the sense of enjoying their work and being better at it. A lot to unpack on this graph, but there's two things to think about. One is how well you're performing. The second is how much you have cognitive load. And in this first column there, you see that when you're acquiring a skill, cognitive load is high and performance is low, and that's when you're first learning a skill. As you develop proficiency, you get better at your job, performance gets higher, but you're still high in cognitive load. You're still challenged while you're doing this work. At some point, you become an expert, and then performance is super high, and your cognitive load is lower. The challenge here is you want to maintain focus. And so even though your performance is high, as your cognitive load goes down, this can be a problem. And this is a famous graph from work from many years ago, from decades ago. And we talk about the Goldilocks zone. And this is that if you're an expert, we want to keep you in this area in which you are sufficiently challenged and are experiencing the right level of load to actually cause you to be doing great work. But we also don't want you to have burnout. We don't want you to be so overloaded for so long that it causes you to do worse at your job or to have effects of well-being. And that's the beauty of studying cognitive load, is that there's sometimes you want it to be increased and sometimes you want it to be decreased. And so we measure both of these during VR use. So about a year ago, I joined with HP, who has been doing this work for well over 2 years. And we started to think about, if we're going to design a system that can detect cognitive load while you're in VR, how would you go about doing this in a supremely rigorous way? And it begins with a dream team, and really credit to HP for putting together, a PhD in neuroscience, a PhD in psychophysiology, a PhD in cognitive psychology, a PhD in HCI, a huge team of machine learning experts, and starting by building a team of experts to really think through, how are we going to study cognitive load? How are we going to build this system that can detect cognitive load? We then built an amazing VR task in which you can measure load, and I'll show you a short video of this. The key here is you're doing this task in VR. You're trying to do 3 things at once. One is a visual task. You're following those dots. The other is an audio task. And the other is a mathematical task. And so you're doing a cognitive task to think about math. You're trying to look around the room and to follow these dots. And you also have to listen for things. And so most of us at work, we've got to think while we look, and listen. And so we designed a task really designed to capture cognitive load inside VR. We then ran a study that is of a more representative sample and a larger sample size than studies I've seen in VR. So we have participants from 4 separate continents, and over 1,000 people have gone through here doing VR while we study their physiology with the goal of understanding cognitive load. Here's a sample of the data, and here on the y-axis you've got the model's prediction of cognitive load, and on the x-axis you've got ground truth as measured by both the task difficulty as well as the participants' ratings of how loaded they were. And what you see here is that the mean absolute error is about 0.1. The model is doing quite well at predicting moment by moment your level of cognitive load while you are doing a task. So incredible data, an algorithm that while you're doing a task in VR, by looking at your physiology, your cardiovascular response, and your pupil dilations, how can we figure out your levels of cognitive load? Now, here's where I'd like to pause and say, it took me a while to think about how to do this work, because if you're measuring someone's physiological responses, their cardiovascular response, and what their eyes are doing, it's important that you trust the people doing this work. And from day one, when I started working with HP, we started talking about privacy, and privacy was the beginning of these conversations, as well as something we revisited pretty much every day that we worked on this. As of today, we're releasing a blog post that summarizes what we're doing on the privacy front, how we're thinking about it, and I'm looking forward to you guys reading this and looking forward to your feedback on it. We are also going to release this data set. So scientists should be able to study data. I believe that the work we've done with HP, we have collected what's one of the best data sets in the history of VR. We've got large sample, we've got the physiological signals, and we've got the outcome related to cognitive load. And we are going to share that with the community so that people can do tests of their own with it. And I'm very excited about that. And I'll just pause here and say, this is the beginning of work. We are figuring out how you can use one's physiology to make their work experience better. We're doing it in a way that's careful, and I'm looking forward to continuing this work in the future. It's my absolute pleasure now to introduce Brianna, the product manager, who's going to give you more details about this product. Thank you for your time.
Thanks, Jeremy. Now that you've seen how Omnicept fits into HP's vision of the future, as well as seen the details of the science behind the technology, I want to dive into the details of the HP Omnicept solution. This solution is founded on a groundbreaking new headset, which we are calling the HP Reverb G2 Omnicept Edition. I'm going to let this next video highlight some of the key features of the world's most intelligent headset. As you saw in the video, our headset is the first to combine eye tracking, pupillometry, a heart rate sensor, and a face camera to provide insight into the human condition. In addition to allowing developers to track what the user is looking at, the eye tracking also enables foveated rendering, which discerns where the user is looking and focuses the GPU rendering in that area. The heart rate sensor allows developers to see changes in the heart rate due to stimulus, and the face camera can capture facial expressions during an experience. This headset also includes all the amazing features introduced in the HP Reverb G2, such as industry-leading lenses, Valve-designed ear speakers, and the 4 cameras. Although the hardware itself is groundbreaking, we don't stop there. In order to take advantage of all the data coming from the headset, we've designed and built a software development kit that makes it super easy to integrate the sensor readings into applications. What's even cooler is that this software solution includes a machine learning cognitive load inference engine. These machine learning models detect patterns in your biological responses and use those patterns as a way to understand how well someone is processing the information that's being presented to them. For example, imagine a pilot training in a VR simulation environment. The pilot may score well in the scenario, but her performance is only one piece of the story. The trainer and trainee might want to know more information, such as how effortful was the training? Did she sail right through, or did she struggle to finish? With HP Omnicept integrated into that flight application, the trainer and trainee can gain critical insight into the pilot's real-time experience, enabling personalized content and the challenges that are within her zone of optimal learning. With HP Omnicept, we are doing real-time analysis and aggregation of biological data in response to simulations during a VR experience. This allows HP Omnicept to provide valuable insights into a user's VR experience. We can get insight into a cognitive load and emotional response and answer additional questions, such as how much mental energy are they expending? Are they able to perform well under stress? Are they excited about certain features in a new product? This is a vast improvement over today's static VR environment. We create VR experiences that can be dynamically adapted to individuals. XR experiences will become data-driven, no longer merely relying on purely subjective feedback loops. Alongside the SDK, HP has also created a developers portal, which will have the SDK ready to download with easy-to-follow guides to integrate Omnicept into applications written in both Unreal and Unity. We are targeting developers at ISVs and developers at enterprises, and we have a flexible business model. For ISVs that will resell applications, we have a revenue share agreement. And for enterprise customers, we have a separate software licensing model. For individual programmers or academics who just want to know their heart rate while immersed in VR, we support that too. Our goal is providing an open ecosystem for developers to create the future. Next, I'd love to show you a video summarizing what you heard about today.
Introducing HP Omnicept, an intelligent XR platform that completely changes the dynamic of how humans interact with technology. Sensors in the headset monitor muscle movement, heart rate, pupil size, and gaze to capture the levels of brain power exerted. Now, users' natural responses drive their experiences in the moment. By combining sensor data with machine learning, software developers get real-time insights to tailor XR experiences for faster and better outcomes. Across industries, HP Omnicept is powering advanced XR solutions that can adapt to each user. Redefining how we train, improve well-being, create, and collaborate. HP Omnicept powered apps help ensure the capture and transfer of data comply with GDPR, keeping user data confidential. Groundbreaking hardware meets transformative software. This is HP Omnicept, a revolution in XR.
As you've heard today, HP is the first to provide both the hardware and software platform that allows for this one-stop experience. With privacy and security built in, it includes integrated sensors, proprietary HP sensor fusion algorithms, and the HP inference engine. This extensible platform allows developers to focus their experience on the VR experience itself, since they don't need to do the additional work of developing algorithms to capture and calculate the true state of the user. To continue learning more about HP Omnicept, please join us right after this for a virtual booth in the expo. Or if you can't make that, feel free to join us at one of several other virtual booth sessions over the next few days, in which we'd love to answer your questions and talk more. You can also tune in to an upcoming panel to hear from several ISVs who are already using HP Omnicept. In addition, you can find more information through our website anytime at hp.com/omnicept, or dive into the details for developers at hp.io/omnicept. Thank you for your time, and I hope you enjoy the rest of your conference.